Okay, we're going to have a look at covalent bonding. A reminder of the periodic table. Here's a diagram of the periodic table. On the left-hand side, you've got metals. There's a bit of a squiggly line here. On the right-hand side, we've got non-metals. Now, covalent bonding is always between a non-metal and another non-metal. There we go. So, know that a covalent bond is formed between atoms by the sharing of a pair of electrons. First, and probably the easiest example to look at is hydrogen, H2. Here's an atom of hydrogen, and you should, from the periodic table, remember the hydrogen's got one electron in its outer shell. Because the formula is H2, we need two hydrogens. And you'll see here that the right-hand hydrogen needs just one extra electron here to get a full outer shell of 2. This is the first shell, and the maximum that you can have in that shell is 2. So ideally, this electron here is going to move across to here, but if it moves across, this hydrogen atom has got no electrons. So if this electron here was to move across here, this would have 2 electrons. So if we're careful about how we draw this, and we have these 2 electrons being shared, this electron has moved to here, but stayed in here. This electron has moved to here, but stayed in here. There's the diagram. Then we find that those 2 electrons there form a covalent bond. 2 electrons, 1 covalent bond. And there's your hydrogen. And you'd normally draw a H bond H. That's one example. Oh, sorry, before we move on, you need to check that each atom has the correct number of electrons that it started with. That's the group number. Hydrogen's in group 1. So hydrogen's got 1 electron. Hydrogen's got 1 electron. And does each atom now have a full outer shell? Outer shell has 2 electrons. Outer shell has 2 electrons. Let's move on to the next example. Chlorine, Cl2. Chlorine is in group 7. Check on the periodic table. Pause if you need to. Here's another chlorine atom, also obviously in group 7. 7 electrons in its outer shell. This atom, needs to gain 1 electron, and it can only gain it from the other chlorine atom. This atom here has 7 electrons. It can only gain 1 electron from the other chlorine atom. So again, if we're careful with how we draw it, here's my left-hand chlorine atom, and the right-hand chlorine atom joins together. Here's the sharing of 2 electrons. So this electron has not left this shell, it's now joined this one as well. There it is. And this electron has not left this shell, it's now joined with this one. Here it is. And that's what makes our covalent bond. And remember, from the last example, 2 electrons gives 1 covalent bond, and we'd show that as Cl bond Cl. That bond, that line there, is your covalent bond. Again, let's check, does each atom have the correct number of electrons? Chlorine has got 1, 2, 3, 4, 5, 6, 7. It's in group 7. Chlorine, 1, 2, 3, 4, 5, 6, 7. It's in group 7. Does each atom now have a full outer shell? 2, 4, 6, 8. Yes. This one, 2, 4, 6, 8. Yes. Let's have a look at our next example, oxygen. Oxygen is also O2. Oxygen is in group 6, so 6 electrons in its outer shell. 6 electrons in its outer shell. Now here, the right-hand oxygen wants 2 electrons. It can only get it from the left-hand oxygen. The left-hand oxygen wants 2 electrons. It can only get it from the right-hand oxygen. So if we draw it together, here's my left-hand oxygen and the right-hand oxygen. So this oxygen here started off with 1, 2, 3, 4, 5, 6 electrons. It's now gained this electron here and this electron here, these 2. And this atom here adds 2, 4, 6 electrons, and these electrons from here have now moved across to here, and now they're being shared. So there is my covalent bond, but actually 2 electrons equals 1 covalent bond. That must mean 4 electrons equals 2 covalent bonds, and we'd show that with a double bond sign there. Again, check, does each atom have the correct number of electrons? Group number, oxygen, 1, 2, 3, 4, 5, 6. It's in group 6. Oxygen, 2, 4, 6. It's in group 6. Does it now have a full outer shell? Oxygen, 2, 4, 6, 8. Oxygen, 2, 4, 6, 8. It all works. A couple more examples to look at. Carbon dioxide, slightly more complex example. Here's oxygen in group 6, 6 electrons. Carbon is in group 4, 4 electrons. And oxygen is in group 6, 6 electrons. And I've shown the electrons in different ways, using X's circles and black dots. So the carbon needs 4 more electrons to get a full outer shell. It's probably going to get 2 from the left-hand oxygen and 2 from the right-hand oxygen. The oxygen on the left-hand side needs 2 electrons, 2 from one carbon, 2 from the middle carbon. The right-hand oxygen is going to need 2 electrons, 2 from the carbon. So if we draw it carefully, here's my left-hand oxygen. The electrons are there and now bonded with the carbon. The carbon shares meanwhile in return 2 electrons. Here's my right-hand oxygen sharing 2 electrons, and again the carbon in return is sharing 2 electrons. So here is 4 electrons. Remember now 4 electrons is a double bond, and another 4 electrons is another double bond. So we've got 4 electrons, 2 covalent bonds on the left-hand side, and 4 electrons, 2 covalent bonds on the right-hand side. And again, we would draw it like that. So here we've got this bond here is not one bond, it's 2 bonds. There are my 2 bonds. Here, 2 bonds. And again, let's just check. Does each atom have the correct number of electrons? Oxygen, 2, 4, 6. Oxygen, 2, 4, 6. Carbon, 1, 2, 3, 4. Correct? Does each atom now have a full outer shell? Oxygen, 2, 4, 6, 8. Carbon, 2, 4, 6, 8. Oxygen, 2, 4, 6, 8. Great. Now some examples for you to try. Fluorine, hydrogen chloride, water, nitrogen, ammonia, methane. Last thing to say is the covalent bonds in terms of electrostatic attraction. So this hydrogen here, the nucleus is positive and it's going to be pulling these negative electrons. So there's a pull this way, but of course the electrons are pulling in return the positive nucleus. So this combination of pulls, this electrostatic attraction, holds this and these electrons together, but at the same time, this positive nucleus over here is pulling these electrons as well, which is what holds that whole molecule together. It's electrostatic attractions from the nucleus and the electron, nucleus and the electron. Hopefully that makes sense.